Okay, welcome everyone. This is your lesson for this week, today, which we are talking about trig functions. Okay, so trig functions, your essential questions for today are what is sine, cosine, and tangent? And B, how are we going to use these ratios to solve the problems in class? I kind of already answered the first one, what is sine, cosine, and tangent, with the second question. They're ratios, okay, of sides of a right triangle. All right. So if we look at this right triangle, ABC, right, we can see that side C or angle C is 90 degrees. In a right triangle, the right angle is always going to be your biggest angle. Okay. And you guys can kind of reason your way through on why the 90-degree angle here is going to be the biggest angle. Okay. So if that is the biggest angle, the side opposite the biggest angle will create the biggest side because, right, you can think about the space between the two endpoints of the angle. So in terms of, let's say I draw this angle out, right? And let's say I draw this angle out. In order for me to make a triangle, right, with the endpoints of the angle, I need to connect this one like that. I need to connect this one like that, right? It's kind of off, but you guys can see the picture, right? Obviously, this angle is bigger than this angle here, right? And the side opposite that angle, in order for me to close up this angle to make a triangle, is going to be longer. Yeah. So that's the reason why the largest angle, which is the right angle in a right triangle, is going to be the longest side. The side opposite the 90-degree angle is going to be the longest side. And in a triangle, who knows what the longest side is? The name. The hypotenuse, right? So this side is called the hypotenuse. Okay? And the other two sides are going to be labeled in terms of the angle that you're dealing with. Okay? So let's say, for example, we have angle A. And we're looking at it from the viewpoint of the angle A, and I love to draw a person here. Yeah. If I'm looking at it from the viewpoint of this angle A, then BC is the opposite side, right, of angle A. And AC here, this last side, is called your adjacent side because adjacent, that word means next to. So it's next to angle A. And obviously the hypotenuse is also next to angle A, but then we call that side our hypotenuse. Okay? So for short, I am going to label O opposite as O, adjacent as A, and hypotenuse as H. Okay? So like I said before, the sine, cosine, and tangent, what they are, they're just ratios of the sides. Okay? So the sine of angle A is always going to be opposite O over hypotenuse, H. Okay, that's the ratio. Whatever your two sides are, right? It's going to be the opposite side over your hypotenuse. Cosine of A is going to be the ratio of adjacent over hypotenuse. Okay? And the tangent of A is going to be the opposite over adjacent. All right? So these are your formal notes. Lastly, what I'm going to say is, yes, you have to memorize this, but there is a easy way to memorize. Yes. No. The short side's never is not always going to be the opposite side. Okay. Because if you look at it from the viewpoint of B, let's say there's a person here, right? Yeah. This side here from her viewpoint, B, is opposite. Yeah. And from her viewpoint, the opposite side for angle A is your adjacent. Yeah. Okay, so you can't just think of it as a short side because it depends on what angle you're looking at it from. Okay. But there is a kind of like an acronym that you can kind of memorize. I'm not too sure if you guys heard it before, but sine is opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So tangent T O A. So SOHCAHTOA. Yeah. SOHCAHTOA is the acronym. And you guys, if you guys are like on YouTube and looking at like math stuff, which we rarely do besides my videos, you guys can see this all the way throughout. Yeah, there's a lot of videos on SOHCAHTOA and there's songs about it and whatnot, but that is the acronym. Okay. So now we're just gonna go through some examples about how to use them, and then I'll dive into our train of thought. Okay. So here is really simple, right? We keep it really simple for now. Which segment is opposite to angle K? So here is the person, right? You don't have to draw the person every single time, but I just like to. Okay, there's angle K. Which side is opposite? Is it KV? Is it this side here? Is it 1? Is it side 1, side 2, or side 3? With your finger, 1, 2, or 3? 2, right? Yeah, it's 2. So your answer, and you guys would just go VJ and just submit your answer like that. Okay, simple, really simple. All right, next one over. Which segment is the hypotenuse? 1, 2, or 3? 3? Yes. So it's OD or DO. So check that box and then just submit your answer there. Express the trig ratio as a fraction in simplest form. So there's 3 parts to this, right? Sine of P, cosine of O, and sine of P and cosine of O. And there's a drop-down menu. Okay. So sine of P first. So P is right here, right? we're looking at it from the viewpoint of this angle. If we're looking at it from the viewpoint of that angle, let's label the sides first. Okay, all the sides. What is this 25 PO? Is it the opposite side, the adjacent side, or the hypotenuse? 25. Yes, it's the hypotenuse. Yeah, because it's opposite the 90-degree angle. Okay? And if you're looking at it from the viewpoint of this angle P, 7 would be your opposite side, and 24 would be your adjacent side, correct? Okay? So in order for me to get the sine of P, and we need it in simplest form, we're going to go sine is so, right? In so katoa. So if you know the letters are going to be O, H, and A, the only way I can write so is S-O-H, right? So I know it's going to be opposite over hypotenuse. So opposite side is 7 over hypotenuse, which is 25. So that's the ratio of sine of P. Okay? So that's the viewpoint of angle P. Now it says to get the cosine of O, of angle O, which is right here. Right? That's angle O. And then if I want the cosine of angle O, I'm going to first have to label the sides. Okay? My hypotenuse, class, my hypotenuse will always be the same. Because that's always going to be the opposite of your largest angle. Okay? It's always going to be, so this one is still going to be H. Okay? These two, opposite of angle O is 24. So that's O, right? The opposite. And then 7 is your adjacent side, A. I have to get the cosine of angle O. So cosine is ka. And the only way I can spell ka is like that. So ka toa. Right? So it's going to be 7 over 25 again. Okay? And then if you push this button, the drop-down menu is going to be, is sine P and sine O equal or not equal? And you can obviously tell, right, from 7 over 25, 7 over 25, they are going to be equal. Okay? That's all you do there. And class, this brings up a great point. Can we come up with like a rule that you guys can see? Is this always going to happen? Where the sine of one angle equals the cosine of the other angle? And disclaimer, class, we're never going to look at it from the viewpoint of the 90-degree angle. Okay? It's always going to be the other two angles. Because if I look at it from the viewpoint of the 90-degree angle, my hypotenuse side will also be my opposite side. Okay, and that just messes everything up. All right, you guys can think of it like that. So is this always going to happen? Is my O and my A always going to switch in terms of the viewpoint? 1 for yes, 2 for no. Come on. 1 for yes, 2 for no. Yeah, they're always going to happen, right? These two sides these two sides here and here are always going to switch depending on where I'm looking at it from, right? Am I looking at it from angle P or am I looking at it from angle O, right? It's always going to change and my hypotenuse will always stay the same. So the sine of one angle is always going to be the cosine of the other angle. All right? Okay. Next one, we have this. Sine of E. Let's label our sides first. So here's E. Right? I'm looking at it from the viewpoint of that angle. Opposite the 90-degree angle is your hypotenuse, H. Opposite angle E is your opposite side. And right next to it is your adjacent side. Right? And then we have to get the sine of E, which is opposite over hypotenuse, or so again, right? So sine of E is square root of 21 over my hypotenuse, which is 11, right? And what we just went over, cosine of F, that's the other angle here, right? This angle here, cosine of F, right? And if I'm looking at it from the viewpoint of that angle, my A becomes my O. My opposite side for angle E is going to be my adjacent side for my angle F. And my hypotenuse will stay the same, right? Because that's the longest side, just doesn't change. So cosine of F is going to be square root of 21 over 11, right? Which is the same number as this because of what we just talked about, right? About how the sine of one angle equals the cosine of the other angle. All right? Okay. Here we just have to find the value of x, sine of x. Find the value of the sine of x. So it's not going to be a drop-down menu, right, anymore. It's just going to be submit your answer type of thing. So I look at it from the viewpoint of angle x. 22 here is my opposite side. Opposite my 90-degree angle is my hypotenuse. And right next to it is my adjacent side, right? That's how we label. So sine is going to be so the sine of x equals 22 over 29. Oops. Okay. Equals 22 over 29. All right. Cool. Questions so far? No? Fairly simple. But now what if I have to figure out something? Like there's a variable here that I got to figure out, right? We got to solve for x. Round to the nearest 10th if necessary. This is when you need a calculator. Okay? So you guys all see these three buttons, sine, cosine, and tangent? That's what we're going to be dealing with. Okay. So if you look back at your at the problem that was given, right? 44 degrees, and I have X and I have 9, right? So before we use these 3 buttons, okay, we're gonna set up the problem. Okay, before we go ahead and use the calculator, we have to set up the problem. So since the 44 degrees is given to us, I'm gonna use that, okay? I'm gonna use this angle, angle C, and set up the problem just the way that we've been practicing, okay? So I'm looking at it from the viewpoint of this angle, 44, or angle C, right? I know that opposite my hypotenuse is X. Opposite my 90-degree angles, is my hypotenuse. I know that opposite this 44 degrees is my opposite side. I know that right next to it is going to be my adjacent side, right? I'm going to label the sides first. That's my first step. Label the sides first. Label all the sides, okay? And then after that, try and set up the ratio with the given sides, with the sides that you have information for. So I have this 9 side here, right? And I have to figure out what X is here. Yeah. And I set up the person, or I'm looking at it from the viewpoint of this 44 degrees here. So if I use A and H, what deals with A and H? What ratio? Sine, cosine, or tangent? Sine, cosine, or tangent? Cosine. Yeah. So cosine of 44 degrees equals adjacent over hypotenuse, or 9 over X. Okay. Before I touch the calculator, okay, before you touch the calculator, I need you to solve for X. Okay, algebraically on paper. All right. So as we solve for X, what are we going to do to solve for X? Well, if your variable X is in the bottom, what we do to solve that is we're just going to get what's here and what's here, and we're just going to flip them. Okay, switch positions. So X is going to equal 9 over cosine of 44 degrees. All right. Okay. So that's my answer without the calculator. And with the calculator, okay, so there's my answer. And with the calculator, what I'm going to do here is I'm just going to first, on the calculator itself, I'm going to make sure it's in degree mode, DEG. Okay, radians and gradients, we're not going to touch in this class. Okay, you guys will learn that in pre-calc. Okay, radians. So I'm going to make sure it's in degrees. If it's underlining the other ones, just go to degrees, DEG, and just press enter. So your calculator is in degree mode. I'm just going to go 9 divided by cosine of 44. And that's my answer. 12.51, right? It says to round to the nearest 10th. So 12.5 is your answer. Right? So X equals 12.5. All right? So what does that mean? That means that this side here has a length of 12.5-ish around, right? Okay. And then my opposite side, if there were to be like a variable here, let's say it's y, right? And I gotta figure out what y is. You can do one of two things. You can use the Pythagorean theorem, right? A squared plus b squared equals c squared to figure out what y squared is, right? That equation would be a squared 9 squared plus y squared equals 12.5 squared. Yeah, and to do that algebra, to figure out what y is. Or you can use sine, you can use tangent, you can use the other two ratios that we did not use to figure that out. Okay, it's up to you. All right, cool. Any questions on this before we move on? No? Okay. So moving on. This one. Solve for y. So again, with this, in this case, we are going to look at it from the viewpoint of angle C. Okay, so there's my angle, there's my person, angle C, right? I know opposite the 90-degree angle is my hypotenuse, so that's my H. I know opposite of 23 degrees is my O, my opposite, right? My opposite side. And right next to it is my adjacent side. Okay. And here is the new part that we're kind of learning. Besides this, right? I have 23 degrees, so I'm using it, right? I have 9.5, that's my O. And I want to figure out what X is, and that's my A. So you have to think, what deals with O and A? What trig function deals with O and A? Tangent. Thank you. Tangent, right? So the tangent of 23 degrees equals opposite 9.5 over adjacent, which is X, right? And again, if my variable is in my denominator, what we do here is we're just gonna change positions. So then this would be X equals 9.5 over the tangent of 23 degrees. And now if I drag this over and I just plug that in my calculator, which would be 9.5 divided by the tangent of 23, that's 22.4, right? Round to the nearest tenth. So X equals 22.4. Cool? Yeah. Okay, and then you can use the Pythagorean theorem again, or you can use the other trig functions to figure out your hypotenuse. All right. No, we cannot use the 90-degree angle. Because I explained it to it simply, right? There's more reasons behind it, but we never in a right triangle use a 90-degree angle because you can think about it like this. If I use this angle here, right, to figure out my hypotenuse will be my hypotenuse and my opposite side, right? So there's no other opposite sides. So just based off of that, right? And I'm just trying to keep that reason kind of simple because we're learning so much right now. So you guys can just think about it like that. It's just gonna mess it up, okay? 90 degrees, it holds special values because it's a 90-degree angle, and we're not gonna touch that right now. Okay. We get this one, right? Can we skip this one? Yeah. Okay. Let's try this one. What happens if your variable x is an angle? First step is always going to be the same. Okay. I want to figure out what x is, right? So this is my person that I draw, right? Angle P. Label the sides. So I know opposite the hypotenuse is going to be, or opposite a 90-degree angle is going to be my hypotenuse. Opposite angle P is going to be my opposite side. And right next to it is my adjacent side. Okay, label the triangle. That's your first step, regardless of what it's asking you. You don't even have to read the directions, right? If you know you're doing trig, and if you know you have a right triangle, go ahead and label the sides. Okay? So I have A, 65. I have my H, which is 75. And I want to know what x degrees is, right? So what trig function deals with A and H? What trig function deals with A and H? Cosine. So the cosine of x degrees equals 65 over 75, right? I have no idea how to simplify that. So I'm going to move to my calculator and I'll show you guys how to do that. Okay. Okay. You guys see the buttons above sine, cosine, and tangent? It says sine to the -1 power, basically. Cosine to the -1 and tangent to the -1. That -1 power is not to the -1 power. It's the inverse of sine, cosine, and tangent. So algebraically, if we want to solve for x degrees is going to equal cosine inverse of 65 over 75. We're going to type that into our calculator. Okay? So get your calculator. If you have a screen that types, you have to push second, cosine first. Okay? And you guys know that on a calculator, it's color coordinated. So if you look at above the sine, cosine, and tangent, right? They're all blue, right? They're all, in blue. So we have to use the blue button second. All right. And on a graphing calculator, there's more colors because there's more buttons. Okay, just FYI. If you guys don't know how to operate a calculator, follow the colors. So the inverse cosine of 65 divided by 75. And again, if your calculator types out like this, you have to push the cosine inverse first, inverse of cosine first. If your calculator just spits out numbers, right? It just has a screen, one screen, doesn't have the typing screen, then you have to go 65 divided by 75 equals first. And then push the second cosine to get the inverse of that. Okay, so it's just the order matters depending on what type of calculator you have. So when you equals 29.9, right? Nearest tenth. So it's 29.9 degrees. Okay? Cool? Like if you're on your iPhone, you would have to type out 65 divided by 75 first. And I'll show that to you guys using my iPhone. Okay? So if you landscape it, right? The sine, cosine, and tangent button always comes up, right? If you put second, those buttons turn into inverse. Okay, I don't think I can I don't think I can focus in on this because of the screen. So if you put 65 divided by 75 first equals, that's 0.86667. And then put second cosine. Yeah, 29.9. Okay, so you end up with the same numbers. All right. Cool. So this x degrees equals 29.9 degrees. Okay. Okay, questions so far? Yeah. The other problems, why didn't I use the inverse for the other problems and why did I do it here? The other problems that were given, right? We were figuring out a side. Yeah. And we already know what that angle is. I can type out whatever this was. This was the tangent of 23 degrees, right? I can type this guy out. When you're trying to figure out what the angle is, that's when you use the inverse function. Okay? Like this one. I don't know what angle. I'm trying to figure out what angle this is, right? So here's my person. Yeah. So opposite the 90-degree angle is your hypotenuse. Opposite the angle itself, right? Angle J is my opposite side. And right next to it is my adjacent side. So again, I have A and I have H, right? Yeah. I have 19 and 25. And I want to figure out what angle J is. Okay. So what trig function deals with A and H again? It's cosine. So the cosine of x degrees equals 19 over 25. And going back to your question, right? I don't know what this is. Yeah, I have to figure out what x is. So in order for me to figure out what x is, I have to get rid of cosine. And how I get rid of cosine is using the inverse of cosine. Okay? And you just plug that into your calculator and get that value. Okay? So I will show this to you one last time with the calculator so that we get it. So the inverse cosine of 19 divided by 25, 40.5, right? That is going to be your answer here. 40.5 degrees. Okay. Any questions so far about this one? Fairly simple. Okay. So we figured out a side. We figured out how to get the angle, right? And that's about it, guys. Okay. that's it for today for these two lessons. And next time we meet, we are talking about special right triangles. And this is also a big topic, okay? That's gonna follow you not just for this class, but for the next, from this class on. This topic is gonna come up. All right? So that's the lesson for today. Thank you guys, and I'll see you guys on the next one.